Enzymes are proteins. Proteins are made in... No, I'm saying that proteins are made from ribosomes, and that ribosomes create proteins in turn. Ribosomes are made up of ribosmal RNA and some other components and stuff. And what they do is that this the big glob called the ribosome takes in some messenger RNA, which is just a single strand of base pairs, generally a replication of regular DNA. But it takes that in and it kind of reads it like a typewriter. Like it just slides into the edge of a ribosome, and then the tRNA that's in the ribosome, the other kind of RNA, it immediately matches base pairs that appear on the messenger RNA, and they just keep doing that and doing that until they create an amino acid sequence. The base pairs on it are like made up of amino groups and stuff. So by the time by the time they create a good amount of amino acids, they just cut themselves off, and they do this 2 at a time. So when they have to whenever they have 2 amino acids ready, they just form a peptide bond, and then that goes on to form more bonds, which are then called polypeptide bonds, and they are proteins. Well, proteins are made up of a lot of amino acids and peptide bonds, but sometimes you can have just, I mean, that's the general gist of it. Proteins are made of amino acids, but you can't necessarily have only 3 amino acids and put them into one protein. It just doesn't work like that, because proteins have 3 structures. The primary structure is just a flat out amino acid sequence, and they're all just laid out, like if you write it down on paper, you just lay them out in like a big row. And then the secondary structure comes from hydrogen bonds that appear because amino acids, they all have a hydrogen head. Like in the general structure of an amino acid, it has a hydrogen on the very top of it. So hydrogen bonds are really weak bonds. Simply, well, I'm kind of explaining something that is actually happening in your body right now. So I mean, you don't have to shut up, but I kind of want to finish what I'm saying. So the hydrogens often form these tiny little bonds that are really, really weak. So the bonds sometimes can shift the shape of the amino acid sequence, and so it can form 2 structures. It can form a pleated sheet, which is kind of like if you, I don't know, fold a piece of paper hamburger style and you do it in thirds. It kind of ends up looking like that. And then the other kind of structure that the hydrogen bonds can form is like a spiral structure, where the hydrogens coil up like a little spring, and that can be really useful too. All proteins are like really specific, of course, so this really helps. And then the tertiary structure comes in when the R groups in each amino acid attract and repel each other. So yeah, with their attraction and repels stuff, they can create 3-dimensional shapes after this, and that actually is very important for enzyme work.
That was very mean. You're very mean.
Oh,
You're not nice at all.
I'm sorry. Well, whoever said the creator of 4chan was nice. And anyway, the tertiary structure is made up of those R groups being folded together through attraction and repulsion, and so you have like this one big tangly thing called a protein. And what proteins do is they pretty much build stuff in your body. The really cool thing about this whole protein stuff is that it kind of forms a chicken and egg situation with DNA, because DNA creates proteins. The way they do that is DNA makes copies of itself, and then RNA is essentially just a single strand copy of DNA. RNA, of course, then goes to the ribosome, where the ribosome can build proteins. Conversely, proteins are actually really necessary for DNA to even like replicate itself. Like, you need the enzymes slash proteins, DNA polymerase and DNA heliocase, in order to unzip and build build the base pairs onto the DNA strand. So you kind of need proteins for DNA, but you also need DNA for proteins, and the way that works out is just really silly and like complex, and we really don't know how it happened. But it's some really cool stuff to know, because the fact that it exists is a miracle, and yet the fact that we've had so much time for this to happen, it was really just a matter of time. So I just talked about like ribosomes
Do
and
you believe in
protein.
God?
Oh yeah, dude, of course. I mean, I created God, so